Hello everyone, and welcome back to a new episode of SHENZHEN I. I'm still here with Rose. Hello.
I'm helping!
She may be helping. And we were in the middle of making a patriotic bread assembler, I think? Yes, a sandwich assembler, not a bread assembler. Oof, that would be a different project entirely. The wiring.
Bread is fun, though.
The wiring is all wrong for bread, of course.
And we spent the last episode arguing about geometry.
Yeah. So we've done all this, and what do we still need at least one more muxer, we think. Well, I don't know. We don't know if we need one more for these two.
So let's start by building the bread and flag controller.
Sure.
Because we've decided we need a bread and flag controller.
Yeah, that seems reasonable. We'll put him like as far back out here as we can, which is probably not there, but here. This is the wrong one. He has no simple I/O. We wanted this guy.
Yeah, we definitely want simple I/O available to us. I think you should probably hook up X3 and X8.
I think we need like kind of like this kind of space going, maybe.
Okay.
So we can.
Oh, I see. Sure.
Something like this to get to the flag, and like this to get to bread, and this will need to be a bridge. So actually, let's make the bridge as far west as we can. Right, this is gonna have to bridge over whatever's controlling the other stuff.
Right, that makes sense.
It's not really clear that we need a bridge here anymore. We can just go around, but this uses up the least space.
Yep, and they're free.
Yeah. Now this guy kind of needs a bridge just to get over here, and I don't think there's a lot we could have done about that.
Not without moving it further away now.
Yeah. So what this is going to be real easy, I think. He's just going to sleep X on X0. X0, please. And he's going to test equal of X0 with 2. And he's going to gen 1. No, not 1. Gen. Which one is bread? P1 is bread. Gen P1 1 0. And then if the input was 2, he will then gen. How long is this? 4? 3. Gen on P0 3 0.
Okay.
So we'll send him a single input that's not 2 to say make bread and to make the first bread, and then an input that is 2 to make the second bread.
I think that you will be happier not doing that branch so that you don't have to do anything more complicated on the left and just using the program state to control whether you're on
I think we're going to use this guy's left. I think these are going to be equally simple.
Okay.
Because...
Well, we'll figure it out if it turns out.
I think that all this guy is going to do is send a number to the... Send 2 numbers to the cheese controller.
Right. The bread controller?
No, the cheese controller. Send 2 numbers to the cheese controller, and start by sending a 0 to bread, right. Then send 2 numbers to cheese, or maybe a mux. Wait. Oh.
Well, meat comes after bread.
Right. What I said a moment ago assumed sort of implicitly that there was going to be another controller for the other 3 inputs, but we might be able to make just this guy do it, right?
All right. So let's attempt that.
We decided that it takes 3 to send a pulse over the X thingy. To send one of these waves, basically.
Yep.
Through a muxer to the output. And right now we have used up 5.
Yep.
And we have a total of 14.
Right.
So... we certainly can't control all 3 of those from just this.
Okay.
Right? Because that would be 9, and then we'd have no instructions left to do other stuff.
That seems right. So it sounds like you also need a cheese controller.
Yeah. Given which, it's kind of nice.
Wait. So at this point, do we really want a muxer in on this guy? Or would we be better off parsing it so that we have simple outputs? Manually.
sure even really what this guy is for. If he's not controlling the other three.
He's for dispatching everything. He's the control flow.
Yeah.
Right, he's for deciding whether it's time for bread or time for cheese.
Yeah. So maybe then.
I mean, you might be able to get away with doing that on the very first check. I don't know.
Oh, geez, I don't know about that.
You don't need to do all this, right? Because now you're not going to build that. If you do that, right? You're going to say, is it 3? First, you're going to store 1 and 2.
Store 1 and 2. What are you talking about?
Oh, I see the problem. Never mind. It's not going to work.
Okay.
Because you still need all that and then to control it. So that doesn't work.
Yeah.
So that's what this is doing. Is it's controlling the ordering. That's its essential purpose. You could do that with a smaller chip.
Maybe. So, the other thing that we could have done differently is we're using up this guy's 2 very precious simple I/O ports to read these 2 in a rereadable way.
Right.
We don't necessarily have to do that. You can use this as a 3-bit RAM chip.
Sure.
And then read from it on XBus instead of reading it at its simple I/O pins.
Right. Well, if we're doing that, then there's no reason to have the chip at all.
Not true. Because
you can
read
repeatedly read it from XBus. I see.
Right.
See.
Right, and then this guy could maybe actually use his simple I/O to control 1 or more of the condiment outputs.
Right. I was attempting to suggest that, but I obviously didn't communicate accurately.
Well, it only works if we read from this over XBus, and that's a little bit harder too. Like,
sure.
Maybe we could just have it control the one thing that's really easy, i.e. meat, and then have a separate cheese and mustard controller that reads from this.
Sure, let's do that.
It means we're gonna have to rewire again.
Woohoo! Let's put in a cheese and mustard controller. No, seriously.
No, I don't know. This is such a funny sentence. That's all.
Okay.
I just had a little bit of a giggle there.
I see. All right, well, let's put in a cheese and mustard controller.
Yeah. Okay. Like that. There we go.
Yes. Also, let's build a ketchup robot.
The thing, well, this is. There's no space.
Put it up.
Where?
See where the bread wire is? Make it go higher.
Sure.
Make it go all the way to the top. There. Now you got space. Now all your wires can go under the bridge. Everything is great. Or can
Only
one wire.
Only one can fit under this bridge.
Well, that's fine.
I
you only
mean,
need
that's
one.
all we need, but we also need to somehow get more data out from this guy about what to do with the meat. Right?
Right. How much vertical space do we have?
We are at the limits.
Okay. That's an interesting limitation to run into. Go down a little? I just want to look.
We could move this guy southeast, maybe?
Okay.
I think that still fits, right? Yeah. And that sort of simplifies things because we don't need a bridge here, maybe? I don't know how that helps.
I mean, it would be nice not to have P0 have to go below, but I don't know that you can solve that. I don't think you can. Like, you can put it above instead.
I don't know what you're talking about above and below.
So see this P0 line that goes to the flag?
Yeah.
You're losing space because that wire, you're losing space to the chip in general because that wire is down below. And if the chip were below, you'd have more space above.
Okay. I might see what you're saying. So, like, this is why it seems so great to use...
A muxer, sure.
To use this, right? It's like, ta-da! It's got exactly the space profile we want, exactly the inputs and outputs we want. Oh, interesting. So, we had a problem, which is that we can only fit one wire through here, right?
Right. We also have a solution.
Well, maybe what we could do is just, so like, they can both write to the same wire. They don't have to have separate XBus controllers.
I see.
Right? So we could put both of them on, say, the west side of the bridge, and then have this be an XBus bridge over here.
Okay.
If it turns out that we do need another one, which is not yet like 100% clear, but I guess it's pretty clear.
Yeah, we've certainly decided that we need to build a cheese and mustard controller. I want to build a cheese and mustard controller.
Okay, so let's move this guy southeast, where he's going to get out of all this prime real estate.
Yeah, that seems fair.
We could, in fact, build another bridge. That doesn't help. That just gets us over the same wire again.
Yep.
It doesn't get us over more wires. Alright, so put this guy, like, here?
Yeah.
Is that good? No, he can't reach this yet, then. Right? He needs to be something like...
Yeah.
Yeah, like this.
Not room for a second bridge. Okay.
Something like that.
There is now room for a second bridge. Okay.
You mean here? No, I don't think we can...
Well, you can move this one down, and then you can move a second one up.
Move what down?
So move this bridge down one.
This bridge like that.
Uh-huh.
But it doesn't... Then it... Oh, I think I might see what you're saying. So you're saying to connect it like this.
Yeah, and move that bridge, and then you can put a second bridge above it.
Above it.
Go up. You've got room for another.
Yeah.
Oh no, bridges are 3. But you can put it up left, and then you can get another wire through if you need
But
to.
where?
Put it there, right there.
How does this help me?
Well, you can get another wire through.
To where, though?
Narnia.
Yeah, there's nowhere I can put it.
Well, if you move the bridges left 2 or left 1.
Okay, so now we're looking. Oops. Like, I don't know where this is going.
So that goes to the top bit, and the bridges connect to each other.
Bridges connect to each other. Okay. All right.
See, now you've got another wire through. I'm not saying that necessarily
Okay.
is what you wanted.
Okay.
But I did make you get another wire through.
So your point is that now we could go like this as well as like this, and then but we don't need 2 ways in here, right?
Right. Well, but you wanted them, so I made it happen.
All right. I'm glad we're making progress.
Help it.
All right. Nobody upload this. Nobody share this video, please. This is a disgusting chip.
Can I tell people who we both work for? Or will it just scare everyone?
I don't think I have talked about employment aside from the fact that I have recently started a new job.
All right.
I mean, it's easy to figure out, but.
That's true. You use your real name online like a weirdo.
Okay.
God, we've made such a mess.
Yeah, this is a bit of a mess.
I love how you thought it was only going to take one more episode to solve this.
It might. I mean, I haven't had any 3-parters before, although that first part was a short one. You certainly have made it more difficult than it needs to be.
You're welcome! You did want to play this with me here.
Alright, so this, we're just connecting up this bridge to get it up to bread.
It is a magical bridge to bread.
Yeah.
It is a very long bridge to bread.
And this guy needs to use, like, how is he going to use all of these dang XBus things, right?
Yeah.
He needs...
Also, you don't actually have P0 connected to anything. Oh, P0 is connected to X1 right now.
Yeah, right now it's a mess over there.
And in fact, we can't make that work. We'd have to bridge over where there's a bridge.
Huh?
Because you need P0 to
yeah.
connect to flag.
No, we can just make P1 connect to flag and make P0 go up here.
Whoa. That honestly had not occurred to me.
Like that, kind of, and then, Gimme. Clicking is real hard. Okay. we could do like that.
Gotcha.
And of course this. Where exactly is X0 coming from?
So kill some of that P0. Just after the bridge. No, leave the thing on and get it to the bridge. And now X0 comes from X2
Got
over
it.
there.
Okay. And then we don't need this bridge really.
Yes.
Well, yeah, because we can do like this. Okay. And that leaves us.
Still no further along. Let's build a cheese and mustard controller.
I can't figure out like how.
We'll put it somewhere and build it.
So let's see.
Oh my god, this is terrible.
The first thing.
This is so wrong. We must be doing something wrong.
Yeah. Oh yeah, for sure.
Should we be using RAM? It seemed like overkill.
I don't think that's gonna help. This is already like all the RAM we need. It's amazing.
That's true.
As long as we're willing to read it one bit at a time, and it's like real hard to even read stuff from RAM too. I think. Alright, well.
I mean, should we just scrap all this and start over?
I don't like that idea very much.
Well, would it be faster? It just all seems so.
Yeah.
Okay, well, what we were in the middle of doing was changing it over so that we're not using our precious regular outputs on
Yeah.
the thingy.
But then, like, that's only useful if we're going to use our outputs on actually writing output, right?
Well, we need to write at least one output.
Well,
I
we
see.
don't have enough wires to get
We don't
over
have
there.
enough
It's
wires
like
to get over
impossible.
there.
We just want.
Right.
We want to use.
Gotcha.
I guess like if we're building a cheese and mustard controller,
Right.
then this guy doesn't need to read this crap at all,
True.
right?
True.
We could just remove that.
Okay,
And
let's
then have
do
the
that.
cheese and mustard controller read them and send output here, and have this guy just send output to the meat thing, right?
Well, the meat thing and then the cheese and mustard thing, right? Oh,
Yeah.
send out the meat thing, yeah, and do the controlling. Okay, let's do that.
Okay, so the thing to do then is
And make that a smaller chip. You're gonna be happier if you make the currently big one a smaller chip.
we'll figure that out later.
All
Which
right.
this one?
Yeah.
I'm not convinced.
Okay.
The interesting thing though is to remove all of this wiring, right?
Yeah.
Okay, this is still a bit wonky, but that's life, I guess. We have 2 wires in, even though we don't need that many. And I think just like it'll be easier probably if we flip this guy, and we'll just squeeze him in like that. So that's our one right head into
Okay.
there. This guy and the cheese and mustard controller will both read from something.
Why does that need to read there?
Right, it
We
doesn't.
just decided it didn't.
Yeah, it doesn't. Okay.
And also, why did you turn it around? Didn't we want wasn't the whole purpose to have the cheese and mustard controller read on separate pins?
We want them both reading from XBus, don't we? No, we
don't.
don't. No, you're right. Okay.
Oh, no, we need the cheese and mustard controller to read from XBus if it's going to read directly, because it needs its outputs.
But no, its outputs are going to the muxer,
Oh, okay,
right?
then let's read it. Let's
Isn't-
read it on the easy.
aren't they? We
Yeah,
don't have enough wires to do anything else.
Yeah, the outputs are going to the muxer. Perfect, let's do it. So you don't want it rotated, you want it that way.
Yeah. Okay.
If you move it down one, it's easier, because then it's right on the thing.
Sure, and then just remove these. And then the only reading that we're doing is from here, and we're doing it in the cheese and mustard controller.
Okay, let's build that. What's the worst that can
I'd rather write this guy first.
Okay.
So let's see, what exactly are we doing here? We're,
Determining if it's time to build a sandwich.
yes, which we do by just sleeping and then comparing for no reason.
Yes.
And then we move 100 to X2, that's this guy, saying put on the first slice of bread.
Yep. And we wait a moment while that happens.
Yes. And then we move a 0.
We don't need to move a 0 to x2. So
We're doing that eventually, aren't we? Or we're sending
we're moving a 2
a
eventually.
2, yeah. We're sending a 2 to x2 later. But in between, we want to...
Add the meat.
Yes. Right.
Which we are doing from an x, we've decided.
Yes. So let us... We have not yet placed this guy, so let's place him. Oh. Right, he's reading from these guys. Whew.
Yep.
Okay. Can we wire this? Is it possible? I grabbed the wrong one again on this guy.
Alright, what is... Tell me what the wiring goal is.
Okay, so this guy is using up all 4 wires.
Okay.
He's sending 2 of them as simple I/O to here.
Yep.
1 is X bus to here, and 1 is X bus to here on a shared line with this guy's X bus to here.
Okay, move it up 1.
Okay, that seems pretty promising. So we got to read from there.
Yep.
And
You can go above.
There.
Yep. Oh no, you've got to move it right 1 if you're gonna do that. Because you've got to use x0.
Right 1 is not going to help because that'll ruin this side.
Oh. I bet you're only gonna want 1 bridge there.
Yeah, you're probably right. And if you know what,
Yeah, just move it over there.
we'll just move it over
better,
that
yeah.
way. If we need it, we need it. We can have it.
Okay, so now move it right 1 and you're in better shape.
Yeah. I was looking at the problems on the side, on the right. You're like, move it right. I was like, that's not what I want to do.
Well, you also need to move it right. That's going to be...
Oh, can't.
That's fine. You can just move it, keep it top.
Right, and then we don't need a bridge here. We didn't need to move it. We can squeeze it under like this. But a bridge is probably simpler.
Well, there wasn't room, right? Because it would have hit the P2 wire, the P1 wire before.
Oh, right. Okay.
Whether you needed the bridge or not, you needed room for the wiring now.
Right. Oh my god, how do we get it in here? No!
Just go right 1. You're fine.
No, we need 2 wires. We need to get... This guy also needs to get 2 wires through here. Right?
Okay.
Alright, what if... I think that we may be overcomplicating things by having individual chips be responsible for condiment types. What if this guy here was responsible for taking an XBus input here that was in the wrong format and converting it to an XBus that's suitable for sending out over here?
Sure.
So we would send him a 1 to say meat. And then like a 2 to say mustard and a 3 to say cheese or whatever.
Okay.
And he would be responsible for turning that into the right thing to go over here.
That's an interesting choice.
Because then we have only like 1... The wiring, I think, is simple-ish.
Okay.
And this guy's instruction set can be pretty simple because he reuses his sleep 1 for any number of instructions.
Sure.
I'm not sure exactly what to do with the cheese. Or the mustard, yeah.
Well, you can have 2 sleep 1s and just have a branch.
Yeah. It's just, I'm not sure which one of them is reading the preferences from here, is the problem.
Right.
This guy, I think, could do it okay.
What happens if we just only need to get 1? So connect the currently neat controller just to the cheese and mustard controller. I'm just thinking
like
about
so.
that. Like that.
Yeah, that's what I was talking about doing too.
Yeah. Okay.
Right, is this a wiring kind of like this? Ah!
Yeah.
I guess that would have worked, but...
It was that way.
Yeah. And we would probably make this a bigger chip, and this maybe a smaller one? I don't know.
Yeah, I think that's going to be the thing.
So the idea is it gets an input, and if it says, "Oh, it's meat time," it just
Makes meat.
sends a thing.
Right.
If it's cheese time, it decides whether to send a thing.
Right. Well, we don't need to do that, right? We only need to send it a single signal. We need to say, it's time to do your part of the sandwich.
Right, but then it's sort of devolved to being like the whole thing. Maybe that's okay?
Well, and then also, how does it signal doneness to the other one? I guess we can just put
We don't-
a wire on it.
No, you can just send back over the same wire, right?
Right, okay, sure.
That's fine, but...
I think that's fine, so let's write that.
But remember, we're using at least 3 instructions for every different condiment being output. And this is going to output at least 3. And it also needs to read some stuff from this and write some stuff to this. So, and also like do some testing. Right?
I see the concern. Okay. I would like a tool that is not a rock to bang together.
Yeah, no kidding. So we could grab a bigger one. It fits.
Yeah.
And if that solves the problem, then, great.
Sure.
But does it?
It doesn't solve all of the problem, but it solves some of the problem.
This guy would be taking like 9 instructions just to operate this guy. 3 instructions to communicate with this one.
Yeah.
And then it has 2 instructions left to read this.
3. You told me it was 15.
No, it's 14.
Okay, so 2 instructions left.
Yeah.
To read that.
Yeah, to read this and decide what to do about it, which is impossible because it's going to take us 2 instructions just to read it and make no decisions at all.
Yes. Okay. So that doesn't work.
Right. Which is why I was saying that maybe this guy connects to here and decides, okay, it's time to make meat, and just sends a 1. Then it says it's time to make 0 cheeses, so it doesn't send anything. Then it says it's time to make a mustard of size 2, and so it sends like a 2 or something. So,
right. So this one's job is basically just to take. Oh no! This is super simple. So the thing that this chuck does,
yeah,
is it takes a number and it just sends it high and then back down to low, so that you get. So this one does the 3 instructions, so that you can loop the 3 instructions and have them elsewhere.
You can't loop them because it has to be in the right bit, right?
Right, but that's okay. That's what I'm saying. Is now you can.
Yeah.
Sorry. By having this just write whatever it's got, raise it to high and then lower it.
Right. So that's what I was talking about. I think when I said that this.
Okay, so let's write that code so that we're.
But I'm not. I don't know exactly what that code is. So first of all.
So that code is read from X0.
Fine. And do what with it?
Store it somewhere.
Move it to ACK. Fine. Okay.
Okay, now we would like to put on X1 exactly what we just had on X0. And then sleep.
Oh, I see. So we're gonna send it not a number saying which sandwich component, but a number saying the thing you should write to here.
Yeah, that's what I'm suggesting.
Okay, that seems promising. Okay, so then move X0 into ACK. Well, so why did we move X0 into ACK? Why not just move X0 into X?
Because we might need to test it to see if it's double mustard. I don't know, is the answer.
But if we're gonna do that, well, okay, all right, I see. So you're saying it should do that, and then it should, instead of just mindlessly following that instruction, it should also maybe read this and decide how to modify it a little.
At least for mustard. I think it should do it for mustard and not for cheese. I know that's gross, but it's gonna make everything better, I swear.
I don't think it is, because, like...
It will, I promise you.
Alright.
A million times.
Alright, what do you want to write here?
Okay.
Move ACK to X1, you said?
Yeah.
Got it. Sleep for 1?
Yeah.
Okay.
So if ACK is cheese...
Okay. Cheese is input 10.
Okay. And also,
Wait, cheese is not the one we doubled, though. You didn't
Oh,
want to
you're
check
right.
cheese.
Sorry, attack is mustard.
Mustard, we decided... Oh, jeez. Which one is mustard? No. It's verification. No, I don't want to read that. I want to read this.
No, you
Mustard
don't even
is the
care
one
about
on
that.
2.
Oh, I see. Yes.
Mustard is the one on 2, so that's a 10. That's easy. Okay.
Well, no. If ACK is 10, right, which we read off X1,
Yes.
which is what we're passing to the right.
Mm-hmm.
So we want to know, is what we passed the mustard one?
Yes, which is 10, right?
No. Is what we passed the thing that activates mustard over on the right?
Yeah, that should be... Oh, I see. They're not lined up in... Okay, you're right. So, mustard... Jeez. There we go. Because we don't really know if one... Like, this thing has a spec. I don't know. Let's go read it. But, this is like a DX something or other. Yes. So, allegedly, the pin on the bottom is the ones column.
Okay.
Allegedly. Every time I've needed to look that up, it's been when I had the thing flipped and it was wrong.
Okay.
But maybe when it's facing this way, it's right.
Okay, so let's do that.
But I've commented it with mustard so that we remember that's what it's supposed to be.
Yes, because this is very primitive code.
Okay.
Okay, if that is the case, and whichever pin P1, P0
Okay, yes.
is also 1,
Okay,
then sleep 1 again.
sure. So we're gonna need maybe a bit... No, just...
And now move 0 and you're done.
Yes, move 0 to
X1.
X1. And go back to waiting for inputs here. Or do we want to send this guy back a message saying that we're done? Do we need to do that?
We may.
I think we do, because
do.
this guy doesn't know how long the mustard's going to take.
Yes, agreed.
So let's move 0 to, oh gosh, to X0. Okay.
Okay, so now we actually solved a bunch of problems. I promise you this.
Yeah, I agree.
Because now, check this out. So now we don't need to hook this up to both the cheese and the mustard. We only need to hook it up to the mustard. Yes, that is a funny sentence. I agree.
All right, hook it up to the mustard, baby. How exactly will we accomplish this goal of hooking it up to the mustard?
Well, we're gonna move the mustard so that the mustard's on the other switch. So that mustard's on P2.
Mustard is on... What are you talking about?
Okay, so in the mux, right now, mustard is on P1.
Okay.
We would like it to be on P2. And cheese to be on P1 or 0.
See, I think. Okay, so one thing we're going to need is that, so that we can even hook this up.
Yep, there are going to be more than that. Oh, no, that works.
No,
Okay.
yeah, that's fine. Why is this connected to 3 things? Oh, right. Like that, basically, I think?
No, I don't understand what you...
Oh, we don't need this, right. We don't need this one anymore. No, we do.
No, we don't. It's
Oh.
great. But now we need to get mustard to come out on P2 and put it onto P0. So just connect P2 on the mux to P0 on your
Okay,
your
and
looper.
remove this.
Yes.
Okay.
Which now means, by the way, that if you need the space, you can move that chip up another one.
Yeah. So, we were only storing 2 bits worth of stuff in here.
Yes.
Okay. So,
2 is for mustard. We want mustard to come out on P2, which is the most significant bit.
2 is for mustard. And if it is equal to 2, we want it to come out where?
At the most significant bit.
P2, which is 100. Okay. And then on this one, we still want it to come out on 1. That's
Yes.
cheese.
Yes.
Okay. Looks promising-ish.
So now, this one's job is just to tell it, yes cheese, yes mustard. Yes meat, yes cheese, yes mustard.
Okay.
In that order. Well, so first of all, it has to turn on bread, which we've done.
Yeah. So let's see. Is this wired up? We don't have anything wired up to control this yet, which we need, right?
No, we're controlling that. We built it. It's done.
Oh, you're right.
That's what we just wrote.
Okay, yep. This is too hard. Okay, so we moved 100 into x2. That was make bread.
Yep.
Now we need to say move meat is on 100. 100 onto x0.
Yep. And we know that's always going to sleep 1.
Yes, but the problem is it sends us back a thing anyway.
Oh.
Right?
Well, why don't we only move it back when we're... oh, that's dumb.
Is it dumb?
Well, there's not room to do what I want to do.
Well, so here's the thing, though.
Mm-hmm.
Well, I don't know what the thing is. What I was imagining for a moment was that we could take this and put it like here.
Yep, that's what I wanted to do too.
The problem is that
That doesn't quite work.
I think it doesn't quite work. Because it means that this... Does it work? I don't know.
Oh, I see. So it takes a moment to read the 0 always? I mean, can we just sleep 2 whenever it's mustard?
No.
Okay.
Because...
That's not allowed.
Hello? Why? Oh, port is not yet. It's blocked on right. Yes, you're not allowed to block on right.
Right. Okay.
I wanted to scroll out here, but I'm reasonably certain that if you are not supposed to write...
If you're not
Right.
supposed
Just like here, the cheese took up no time, right?
Ah.
Mustard should only take up 1 time, I presume, if
Gotcha.
there's only 1 mustard.
Okay. Ugh.
This bridge could be avoided by going like this.
Yeah.
Not sure if that helps.
I mean, that doesn't... Well, it does, right? Because now we can make this a longer controller and do slightly more with it.
I
Which
see.
means that then we can make all that branching logic work so that we write 0 when we're done with the mustard, whenever that is. So we just do a giant special case for mustard, and everything else it just sends out.
I see. Okay. So let's rip that away.
Can you copy that code, or do we have to...
Yes.
Okay, good.
And just in case, there it is. But I'm reasonably certain it'll still be there, but I did not want to lose it. So
Yeah.
Off we go. Give us a real chip, please. The big boy chip.
It's such a mess.
Do you want to wire this up to X0 instead? Well, let's paste.
That's a P, so you'd like it on a P, please.
Paste. Oh. Yes, indeed.
So you want to go, you're happier if you go around and over.
Am I?
Yeah.
Why?
Because then you don't have to worry about getting bridges up to the X's quite so much.
But I can just do this.
Okay,
Right?
that's cool.
I only need the 1.
I guess that's true.
Okay, so instead of X1...
1, you've got 0 now.
Well, hang on. So, all the X0s are the same. This is... We want that. Don't we? Oops. No.
Yeah, no, you're good.
No, this is the one that's wrong. It needs to be a 3.
Yeah.
And in fact...
And there's also one where you're moving 0 to X0.
That was to tell this guy that we're done.
No, that's the wrong one. That's not the branched one. You need to move a 0 to X3.
We just...
To X2.
Oh. God,
We had
jeez.
already written a bug.
Okay.
Not on a branch. We always need to move a 0 to X2 when we're done.
Yeah. Okay.
You're going to want to put a label there.
Where?
Right before you move 0 to X2.
Oh, I see. Just done?
Yeah. So you can jump over that.
Yeah. Okay. So let's start over with all this crap.
Okay. So we want to test if it's mustard.
Okay. So first we moved ACK. That's the thing we're supposed to write. To
the writing.
Yeah.
And then we slept for 1.
Yeah. And then we select for 1. And now we want to test ACK for
being mustard.
which
one.
is 1. I'm writing like the same thing, of course, but...
Yeah, that's fine.
And if so, we also want to test equal P0 for being...
No. If it's not, we want to jump to done.
Okay. Fine.
Now, we don't need to do the extra branching.
Okay.
Right, we don't need to case this one. We just do it.
Ooh.
Now if we're here, we're in mustard.
Yes, it's definitely mustard, but now we need to check whether we want extra mustard.
Yes, do we want extra mustard?
Test equal P0 with 100, I guess.
Yep.
And if so, sleep for 1 again.
Yep. And in whatever case...
Move a 0, I guess.
No, we don't. We only want to move 0 on mustard, so that we don't have the extra things to get through.
Right. Okay.
So just above, just after you suck and sleep.
Yes. Also move a 0. I see what you're...
No, we do it all the time. That's
What?
why we jump.
It doesn't matter. We're in... This is all... No, it's... No, I see what
We
you're
do
saying.
it all the time when we have mustard, but not all the
Yes,
time,
got
not
it.
just
Move.
when we have extra mustard.
0 to x0.
Yes.
Okay, so...
That's what I was aiming for.
Yeah. Mustard done. Must done. Oh, no room.
You've got enough room to put a comment on the line below. That's terrible. Okay.
All right.
Great.
So that's exciting.
So now we can make this work.
Yeah. All right. So we sent a thing to bread here.
Yep.
And we slept for 1 because now the bread's done.
Yep.
Then we sent 100 to this guy saying
Meat.
to put on some meat. And we're not gonna sleep because we're not waiting. We're just gonna sleep 1 basically, right?
Yeah, we want to sleep 1.
Yes, because if we don't, then we'll be blocking on a right that no one will accept, right?
Yeah.
Let me just confirm that I understand how that works. Let's move another 100 to x0, even though that's obviously wrong.
Okay.
And see what happens here. Oh, we raised the flag.
Whoops! Let's fix that.
Nah, whatever. We're working on something else right now. So we now send 100 to x0.
Uh-huh.
What's happening?
It's waiting on x0. I'm not sure why.
Oh, it should be 3.
Oh yeah! Good call. Good call. Well done us. Raise the flag.
Okay, we sent 100 over. It
Yeah.
got the 100. It said, oh, let's write that as...
So we're
Meat?
still waiting on the 100.
We lit up the meat. No.
Yeah, we lit up the meat. That's good.
Great. Now we're sleeping for 1, but we're blocking on this right. Yes, so let's advance and make sure that that's what it's upset about. Yes, blocked on right. Okay, so we cannot do that.
We must sleep.
We must sleep 1.
Okay. Now, if cheese, write
Right.
cheese and sleep 1.
All right, so we're going to test equal
P1.
P1 of 100.
Yeah.
If so, we're going to send x3 cheese, which is 10, and sleep 1.
Yep.
Okay, now we're going to test equal...
You want to move 10 to
yeah.
x3, not x3 10.
We don't actually need to test anything here.
Right, we just send the mustard signal.
Right. Send the mustard signal! The British are coming!
Yes, exactly.
Alright, move, I guess
Move!
sometimes the M key, like, I don't know what it is about the M key, but I frequently fail to press the M key somehow.
Okay.
Move 1 to x3, right? It's a 1 we're sending, we already did
Yep.
10 and 100.
Yep. And then we
And then sleep.
Slicks.
Slicks, right. Slicks for x3.
And then don't forget to read it.
Test equal x3 to x... Not to x3, that would be bad. Test the input whether it's 0, and then, like, ignore that.
Yep.
Okay, and then we move 2 to x2.
And then we're done. We've made a sandwich.
Yeah, we can... Sleep x will work in that case, right?
You don't need to sleep, right?
Well, this sleep is... We do need to sleep.
Oh, I see. Yes, that sleep X should work,
Yeah.
as I understand these things.
Okay, but in the meantime, these are backwards,
Just
right?
P1 and P0 are backwards. So
Yeah, let's just-
swap those.
I just want to confirm that that's what's wrong. Yeah,
Yeah, we just moved that chip around a bunch.
yeah. Okay, this is...
Well, we don't need one of these bridges.
Yeah, maybe a bit messier than it needs to be. Maybe. Get out of here, bridge. Feels like we could have somehow done without that, but whatever.
I mean, I'm pretty sure we can do without this chip at the bottom now, at this
You
stage.
think?
But
I'm not convinced at all.
Well, it's only got 4 lines, and we've got 4 lines of room over there.
But this guy, they're in a loop in here, right?
Right.
We'd have to take it out of the loop somehow.
Right, good point.
All right, let's see what, like...
Well, we wouldn't, right, because it's doing a similar loop, but that's okay.
But it couldn't do the same loop because we'd have to write to a different, like...
Right.
Expander and everything, like...
All that's scary. Gotcha.
All right, so it's now finally time to make a sandwich. Let's see
make
how
a
that
sandwich.
goes. So we move x1 into dat. I forget why. Oh, we're testing what it is. We found out...
It's 3.
We found out that it's 3. I've already forgot what this -1 means, but okay.
Stop making sandwiches.
Ah, yes. Okay, it's 3. So we move ACK, which is our state, into x3, which is this preference module.
Good start.
And we lit up both of those things. That's good.
Yeah.
No cheese, extra mustard.
Yeah.
We move 100 to x2, which is this guy, and he now goes into please make me a sandwich mode.
Yep.
We
Read. So
throw away the thing, yes. And then we move 100 into x2, saying please put on some bread.
Yeah.
And it
does,
yes.
Nice.
There's bread, okay. Now we move 100, oh, we slept.
Yep.
And we move 100 to x3 now. This guy's now ready to start reading.
Yeah.
He just takes that 100 and forwards it along.
Yep.
And then sleeps a bit. We put some meat onto the bread. Now we're testing whether we're in mustard mode, which we're not, so we jump to done.
Yep.
Okay, that's exciting.
We're testing whether we do cheese.
Uh,
We also tested whether we do cheese.
oh, this guy is doing that, right?
Yep.
Wait, move 10 to x3.
But only if we're cheese.
But it's lit up. He's doing that. He's sending a 10 right now.
Oh, we've got it the wrong way around. We want those to be minuses, not pluses. Because if the cheese thing is on, we don't want to add cheese.
Okay. Yes, that sounds correct to me. Okay, so now we say test equal P1 to 100. It is, so we don't make
add
cheese. We move 1 to x3. That's saying it's time to add the mustard.
Yup.
So we step. Why are we writing a 0?
I don't.
Oh,
That's
because
okay, that's
because
okay.
we're this
putting
guy's
that
still
full
this
stop.
guy's still finishing what he does with like the meat or something.
Yeah, we're turning off the meatballs still.
Yeah, but it's still in the same time unit. So he sleeps doing nothing, and then he gets the thing and he writes the 1. He sleeps for 1, and that we're now dispensing mustard. Look at the little mustard
Oh my god,
fountain.
that's adorable!
Okay, we're dispensing mustard. We say, is it equal to 1? Yes. Do they want extra mustard? Yes. Therefore, sleep for 1.
Say, okay, now done with mustard.
Now, no mustard, please. Oh, this guy's still doing stuff.
Yeah, that's okay though.
Oh, that's the X0 we were
Yeah.
sending him.
Everything is good. All is
Yeah,
well.
and now we send this guy a message saying, we're done, no more mustard, please. Simultaneously, we send a 2 to the bread module, who checks whether it's 2, and it is.
Yeah,
So he generates the bread,
yeah.
and then a
The
flag. We made the right sandwich.
Yes! We did
This
it!
is
We made a
amazing.
sandwich!
Can we make a second sandwich? Look at that. This guy wants everything and extra mustard. And we made it. No problem. Wow. Sandwich kings.
We did it.
We're sandwich emperors? China? I don't know. Like, I don't know. Now they have a president
And
or
also,
something.
we are successfully canceling sandwiches when we should.
Good.
So I think we're done.
Yeah.
We did it.
We made a sandwich. Thank God.
We made a sandwich maker.
Mm-hmm. Okay, so we spent more on production and more on power than everyone else, which is not a humongous surprise.
No, God, no.
What a mess. We can see how Scott Manley did it later. Meanwhile, let's receive our accolades. I'm sorry, I really am trying my best to come up with good ideas, but obviously, as you pointed out, I have more work to do in that area. Please give me another chance. I swear I'm going to redouble my efforts and work extra hard to create a successful product for you, I promise. Please disregard the previous message, hit the wrong button. Okay.
Alrighty.
That's a little sad. Okay,
Poor
well,
man.
we did it, guys. It took a little while, but we made a sandwich maker.
Sandwich maker makers!
Thanks, everyone, for watching. Hope you enjoyed, and I will see you next time.